So in this video, we are going to talk about the basic skills test Wonderlic, the quantitative form. So I have the practice test. Now this is an older one, so I can't tell you how long ago this was posted, but this is an older version, but I think this will give you an idea about some of the skills on that basic quantitative portion. Now, you're not allowed to use a calculator, so if you're going to do, for number one here, 58 plus 79, let's just remind you of the rules of that. We are going to first start with our ones digits. 9 plus 8 is 17, so put the 7 down, carry the 1, and then just add down. 1 plus 5 is 6, 6 plus 7 is 13, so our answer is C. Same thing for number 2. Just make sure your ending ones digits line up. And then let's go down the list. Now, if you're doing this without a calculator, you can think about, well, what would it be to add 1,000? So 6,386 plus 1,000 is 7,386, and we're one less than that. So the answer I expect is going to be D, but let's just mathematically check. 9 plus 6 is 15, carry the 1. 9 plus 1 is 10, plus 8 is 18, carry the 1. 9 plus 1 is 10, plus 3 is 13, carry the 1, and it is indeed that. Okay, so you can kind of use logic if you want. Now when you are subtracting, again, we're going to line up the back ones digits. If you can subtract, you're just going to subtract. 6 minus 4 is 2, 7 minus 3 is 4, the answer is C. Now, for a multiplication, let me write it down. So 67 times 2. If you have a one digit with a two digit, it's customary to put that one digit underneath, and we're going to multiply. So just like in addition, you might have to carry. So 2 times 7 is 14. So put down the 4, carry the 1. 2 times 6 is 12. You're going to add that 1 on the top. That's 13. The answer is 134. Number 5, let's do that same multiplication again. 437 times 7. So we're going to start with the 7. We're going to multiply 7 by 7. That's 49. So bring down the 9, carry the 4. Do the multiplication again. 3 times 7 is 21, plus 4 is 25. So we're going to bring down a 5, carry a 2. And then we're going to do next 7 times 4 is 28, plus 2 is 30. So that is 3,059. The answer is C. And then finally, let's do a division. You're always going to put the number before the division symbol under your division box. The number after goes outside. You compare the first digits. Can 8 go into 2? No, there's not enough, so then we use 2 digits. Now 8 could go into 28 3 times without going over, so you're going to put the 3 above the 8 since we use 2 digits. 3 times 8 is 24, so now you're going to multiply and put that number under here. So we're going to put a 24 down there, and you're always subtracting. So then you do the subtraction, you get a 4. 8 can't go into 4, so we bring down the next number. 8 goes into 40 exactly 5 times. And we get a remainder of 0, so it goes into it perfectly 35 times. You can always check division by doing multiplication. If I do 35 times 8, I should get 280. So there's just some basic skills. Some basic skills there. Now let's look at some of the applied problems. It says Elena worked 38 hours last week and 36 hours this week. How many hours did she work in the 2 weeks? So that's the total hours. Just go ahead and add those values up. 6 plus 8 is 14, so bring down the 4, carry the 1. 3 plus 3 is 6, plus 1 is 7. The answer is 74. Now let's move on to 8. In 8, it says an electronic score store had 182 customers on Thursday, 443 on Friday, and 509 on Saturday. How many customers did the store have in those 3 days? So that is a total. So we're going to add those up. Just make sure your back one's digit lines up. 2 plus 3 is 5 plus 9 is 14. So put the 4 down, but carry the 1. 8 plus 4 is 12, plus 1 is 13. Put down the 3, carry the 1. And then we've got 1 plus 1 plus 4 plus 5. So you're just going to do that. 1 plus 1 is 2. And then 2 plus 4 is 6. Plus 5 is 11. So you get an answer of 1,134, which is what we see in D. Now let's look at 9. For 9, it says Susanna earned $65 in tips on Friday. She gave 18 of the tips to the busboy. How much does she have left? So that is implying that you took off $18. So we are going to subtract 18. And so when you subtract, think about the fact we can't take 8 from 5. There's not enough. So that's when borrowing comes in. Just go to the digit that is to the left of your 5. Take off 1. So now that's going to be a 5, and just set the little 1 there. So we want to think about that as 15 minus 8. Now 15 minus 8 is 7. So we're going to bring down the 7. And then remember, we now have 5 left because we took 1 away. 5 take away 1 is 4. And so the answer is 47. Now, you can check your work. You can do 47 plus 18 should be a total of 65. And so you could check your work that way pretty easily. Let's move on to 10. The Wilsons' budget is $90. They've already spent 41. How much is left? So we are just going to subtract. Now you could kind of do many of these in your head. If you kind of round out to 40, if I had $90 and I spent 40, I would have 50 left, but I have 1 less. I spent 1 more, so the answer is 49. But let's do the math out to show you. So what you're going to do is you'll notice that there's a 0 there. We can't take 1 from 0. So because of that, you are going to have to do the borrowing thing. So remember, this becomes an 8, and then we make it a 10. 10 minus 1 is 9. 8 minus 4 is 4. The answer is indeed 49, like I predicted. So now let's look at 11. It says each box contains 14. In total, how many hammers are contained in the box? You can use logic. You can think, oh, there's 14 in each of those. You can add up 14 5 times. But the easiest way to do it is 14 times 5. 5 times 4 is 20, so put down a 0, carry a 2. 5 times 1 is 5, add that 2 on to get a 7. There are 70 hammers total. So now let's look at 12. Linda found 4 boxes of file folders in the closet. Each box contained 24 folders. In all, how many file folders were in the box? So if you think about the fact that we've got 4 boxes here, and I'm sorry my boxes are a little bit ugly, but we got 4 of them. Each one of those boxes contains 24. So that is a visual that can help you. And so you can think about, you could add up 24 4 times. The quicker way is to do 24 times 4. 4 times 4 is 16. Put down the 6, carry the 1. 4 times 2 is 8, plus 1 is 9. There are 96. So there's more than one way to do problems like this. You know, you can use logic, you can use the visuals that I have there, you can use addition or multiplication. I'm going to try to show you the quickest way. Let's look at 13. Now 13 is a division. As you can tell, we have some remainders there. We can, you know, always work backwards if need be, but let me show you how to do this problem. So the 6 to 83, it goes in the box, the 8 goes outside the box. Now 8 does not go into 6, so that means we have to use the first two digits. The closest thing to 68 that's a multiple of 8 without going over is 64, so that's 8 times 8 is 64. So remember, you put it above the digits you're working on. I'm working on this digit here, and then I multiply, and then I subtract, and then I bring down the next thing. And then how many times does 8 go into 43 without going over? That would be 5 times. Put it up there, multiply, subtract. This is our remainder. So we need the answer of 85 with a remainder of 3. So that would be B. Now let's take a look at 14. So that would be 304 divided by 23. Excuse me. We're going to do the same thing. We know the answer is either going to be 12 or 13 with a remainder of something. So let's give it a shot. 23 does not go into 3. 23 goes into 30 one time. So 1 times 23 is 23. Put it down below, subtract. 30, take away 23 is 7. Bring down the next thing. 23 times, it's either 2 or 3, you know, that we have these answers we can always be looking at. 2 times 23 is 46. 3 times 23 is 69. So 3 is what we want. The only one that starts with a 13, we don't even really have to go further, is that one. But let's check the work. 3 times 23 is 69 with a remainder of 5. So that's exactly what C says. Now 15, they want us to use decimals. So we are not going to do the remainder. We're going to keep on going. So let me show you how to do that. But it's the same procedure. 272 divided by 64. Do you see how they've gone out 2 places? So we know we're going to put our dot, going to put it above and below, and we're going to need to go out 2 places. Okay. Okay. So let's go ahead and let's check our work. Now, we know it starts with a 4 or a 3. Okay. So let's think about something. 64 times 3. Let's try that. That's 2. That's 1. 3 times 6 is 18. That's 19. 192. Okay. So 192 definitely would go under 272, but is it too little? Well, 64 times 4. 4 times 4 is 16, carry the 1, 24, 25, it's 256. Definitely we can go in 4 times. So that's 256. Now, if we take 272 minus 256, we'd have to do some borrowing, right? Because that would be 12, that would be 6. 12 from 12 minus 6 is 6. 6 minus 5 is 1. And then we're going to bring down another digit, and we have to ask ourselves, how many times would 64 go into 160 without going over? Ignore the point. We don't even have to write it down here. We know where it goes up above, so if that confuses you, you can write it as 160. 2 times is enough to keep going. So we already know our answer is going to be A, but you can verify. 2 times 64 is 128. 160 minus 128 is 32. Bring down the next 0, and then it actually goes in there exactly 5 times. So that would be 320, and with a 0 remainder, so it's the perfect decimal we want. So the answer is 4.25. Okay. Now let's talk about fractions. To add or subtract fractions, you have to get a common denominator. So think of our number that goes, that 5 and 7 both go into. So If you can't think of what it is, 5 times 7 is 35. So that's a way we can approach it. Now, I don't like to write fractions when I'm doing it mathematically as that little slash. I like to see a top and a bottom a little clearer. So I am going to write it like you see here. To make the number 5 into 35, I'm going to multiply this fraction by 7 on top and bottom. I'm going to multiply this fraction by 5 on top and bottom. And then the rule is, if you get the common denominator, you keep the denominator, you add up the exponents. So the answer is 12 over 35. It can't reduce further. There's not a number that goes into 12 that also goes into 35. So that's your answer. Now, 6 and 48, 6 times 8 is 48. So you could use 48, but there's a smaller number that 6 and 8 go into. So it's usually more effective to use the smallest number that they both go into. That least common multiple of the two is actually 24. Now, if you use 48, it's not a bad thing. You could come back to it. We would have to multiply this by 4 to turn it into a 24. We have to multiply this by 3 to turn it into a 24. 4 24s plus 3 24s, add up the top, keep the bottom. The answer is 7 over 24, C. Now, to reduce a fraction, we are looking for something that can divide evenly into the top and also into the bottom. 15 and 21 are both divisible by 3, so just divide it. We get on top of 5 and a 7 on the bottom. Now, I always just take a moment and say, okay, can I do anything further? Well, there's nothing that can go into 5 that can also go into 7, so you're done, except 1 that doesn't really count. It doesn't change anything. Now let's take a look at 19. Now, the number 16 over 9, since 9 goes into 16 exactly one time, we have one whole thing with 7 remaining. Now, the way you can check your work, 9 times 1 is 9, plus 7 is 16. The answer is D. So that is 19. Let's take a look at 20. Which of the numbers is the smallest? Well, if you can turn it into common denominator, and I think we can do that, 14 times 3 is, let's see, 12, is 42. I believe all those numbers on that list will have a common multiple of 42. It can be any multiple. The smallest is usually easiest. So let's start with 3 sevenths. 7 goes into 42 6 times, so let's multiply top and bottom by 6. We get 18 42. 1/3, 3 goes into 14, 3 goes into 42 14 times. That's how we got the number 42. So if I multiply by 14, that's 14 42. 6 goes into 42 7 times. So if we multiply top and bottom by 7, that's 35 over 42. And then 14 went into 42 3 times. So that's 27 over 42. The smallest one, when they have common denominators, will be the one with the smallest number of 42s, the smallest value on top. So the smallest value on top is 14 over 42. The answer is B. Let's take a look at 21. Kate's hat costs $23.40, her gloves $7.20, her coat $74.95. How much did the 3 items cost? That's a total. Line up the decimal places. So then your place values match up. The answer, you're just going to bring that decimal place down in that location. Okay, so let's do the math. So 0 plus 0 plus 5 is 5. Now we're going to do this column. 4 plus 2 is 6, plus 5 is 15. Now bring the 5 down, put the 1 in its new column. 1 plus 3 is 4, plus 7 is 11, plus 4 is 15. Put down the 5, carry the 1. And then we're just going to add now the ones in this column, but don't forget the 1 at the top. 1 plus 2 is 3, plus 7 is 0, so that's 10. So then we get an answer of $105.55. The answer is D. So that is that one. So, just think, if I have to total something, I have to add those things together. Let's look at 22. Ben's monthly commuting expenses are $109.32 for train tickets, $16.45 for parking, and $68 for the bus. How much are his monthly commuting expenses? So we're just going to, again, find the total of those things. Now, when you do that, if you have a decimal, line up the decimal point as your marker for how they should be lined up. If we add up the first column here, we get 7. The next column here, we get 7. All of those had 77 in the back, so that's a good start. 9 plus 6 is 15, plus 8 is 23. So you bring the 3 down, put the 2 up there. Now we're going to add up those 2, 0, 1, and 6. That's 3 plus 6, or 9. And then we have 1. The answer is C. The next one, we've got this company budgeted $3,050 on advertising. They have spent $1,764. How much is left? Now that's going to tell us that we are going to subtract. So when you subtract, the top value does not have a decimal in there. So put that decimal in there and add 2 zeros to account for where the change is going to go, where the coins, where the pennies are, and our cents, I guess. Okay. And you can use some logic. If I have a full dollar and I take off 25 cents, I have 75 cents left. But let's do the subtraction. Now, we have to go all the way over to the 5 and make it a 4, and that's going to become a 10. But we have to take one away. That's going to become a 9. We're going to put a 10 there. But we've got to take one away. That's going to become a 9. So the last thing you need is going to be a 10. The ones before it, we've taken one off each place, and that's going to be a 9, if that helps. But we know we should get 75. 10 minus 5 is 5. 9 minus 2 is 7. So you can check your work as you go. Now, 9 minus 4 is 5. 4 minus 6, can't do that. So this is going to have to borrow from the 3, make it a 2 and a 10. The 10 is going to borrow, make it a 9. That's a 14. Okay, 14 minus 6. 14 minus 6 is 8. 9 minus 7 is 2. 2 minus 1 is 1. The answer is this. Now, if you really suck at doing subtraction, we can add these together. This is way too much, because we know that it should be less than the 3,000 we started with. So you really are just checking those two. When you add those two up, you would get 3,150, too much. These are the only two that add up to the total we're talking about. Let's look at 24. A nursery sells apple trees for $24.95. They bought 8 of the trees. What's the total? So you can add $24.95 8 times. But if you do $24.95 times 8, that's the most effective way. Now, this is the first that we've had some decimal places, so let me tell you how to deal with that. For first, you just do the multiplication, ignore the decimal places. So 8 times 5 is 40, 0, carry the 4. 8 times 5 is 40, 0, carry the 4. 8 times 9 is 72, plus 4 is 76. Bring down the 6, carry a 7. 8 times 4 is 32, plus 7 is 39. Bring down the 9, carry the 3. 8 times 2 is 16, plus 3 is 19. Bring down the 9 and the 19. Okay, now here's what you do with the decimal place. There are 2 things after the decimal place, so our answer has to have 2 things after the decimal place, so the dot goes here. So that's why our answer is A. Now, there's another way to do it. If I bought 8 trees for 25 bucks, that is $200. But I didn't quite spend $200 because each one had an extra 5 cents. So 5 times 8 is 40. It's $200 minus 40 cents. That you can do that logically in a way. So the only one that's even remotely close to that $200 figure is A. Okay. Again, you can use logic. 25. A repaving crew is putting a new surface on 79 kilometers of road. They have completed 28 kilometers. If they repave 3.4 kilometers per day in the next several days. How many more days will it take them to finish? Now we can make a chart. We can do it logically and we can do it mathematically. I'm going to show you both ways. So they had 79 to do. They already did 28. If we do subtraction, they have 51 to go. Okay, so that's how many is left to go. They're doing 3.4 per day. Okay, so the first day they're going to do 3.4. The next day they're up to 6.8. The next day, I'm doing a little math here. They're up to 10.2. We got 51 to go, remember? And then, you can keep adding on. So this is day 1, day 2, day 3, and so on. So what do we need to know? Well, we need to know how many times 3.4 goes into 51. So mathematically, that's the quickest way to do that division. Now, when we're dividing the outer number that has a decimal in it and the inner one doesn't, put a decimal at the back end. We're going to move this over one place, so we got to move this over one place. So we're really doing 34 into 510. Okay, now 34 goes into 51 one time, so we can do that multiplication, and then we can subtract. 34 doesn't go into 17, so we got to bring down a 0, so that's the way you want your division to work. 34 goes into 175 times exactly, and so we have no remainder, so it is 15 days. Okay, now you could think 10 days would have been 34. It has to be more than 10, and then you could do the math from there. You could also do 3.4 times each of these numbers until you got to 51. So there's lots of ways that you can do most of these problems. Okay, so we've got this picture, and it says a 6-foot-tall man is standing near a tree on level ground as shown in the picture. The man's shadow is 4 feet long. How many feet tall is the tree? So let's put a little mark. Let's make that 6, because they told us the man was 6 feet tall. And let's make this an X because we don't know what it is. That's what we're looking for. Okay. This is a proportional relationship. So I think of height to shadow has to equal height to shadow. Okay. Okay. So let's put the fraction related to the man. Okay. 6 feet height over 4 foot shadow. Now let's do the same setup for the tree. X for the height, 18 feet for the shadow. Now the best way to solve a proportion is to cross multiply. So anything that's in the denominator cross multiplies over. Okay. So it's really going to be 6 times 18. Should be the same as x times 4. Okay. Now 18 times 6. 6 times 8 is 48, carry the 4, that's 108, okay? So we're really looking for what number times 4 would give us 108. And we only have so many to choose from. Logically, think 4 times 25 is 100, so 4 times 27 is 108. The answer is A. Now you could do 108 divided by 4, and you do get 27. But if you think logically of the choices we have, that would be our answer. So we've got a graph. Now, we're going to use this graph for the 3 problems that follows. Anytime you're given a graph, first take a look at what they're calling the graph. It's round and round records, the jazz records that were sold. The x-axis here is labeling the months. So this is January, February, March, and April. So I'm going to even put a little dot at those locations. Okay. And then we know that the number of records that were sold were there. Let's even kind of put numbers on. This one looks, we're just going to guesstimate, but this looks to be just under 1,000, but closer to 1,000 than to 900. So let's put 960. Why not? And then for February, it looks smack dab in the middle, so that looks like about 1100. This one looks to be smack dab in the middle of 16 and 14. And so if you go between there, that one looks to be about 1500. And then up here in April, we just seem to be over the 800 line, or 1800 line, I'm sorry. But we're not even in the middle. That would be where 1900 is. I don't know. So let's call that 1850. And those are guesstimates, but it gives us some information that's approximately what it looks like it is. Okay, so 27 says about how many more jazz records were sold in April than in February. So we've got the numbers listed. So 1850 minus the February number, 1100. So we're going to pick the answer that's closest to what we get here. And so that's 5 and that's 7. So I think the answer is A. Okay. It says 2% of the jazz records sold in April were from a new label. About how many records were from the new label? So that means that 2% of our April figure, 1850, is what we want. Now 2% is the same as 0.02. So if you do 1850 times 0.02, but you can even use logic. 1%, you just divide 1850 by 100, that's 185. So 2%, if you just double 185, you get 370. So based on the number we picked, the closest to that, that's reasonable, I think the answer would be D. It says March sales accounted for 1/7 of the total number of jazz records sold all year. About how many jazz records were sold all year? We know that 1/7 of the total is what we put down for March. We put down 1,500. So the total would be 7 times 1,500. Well, 1,500 times 7 is 10,500. The answer is B. So by looking at your chart ahead of time, organizing the data, kind of labeling what your data is, that makes things go easier. Let's take a look at these ones. Now these are equations. I'm going to walk you through the steps of how to solve it. Now you have numbers on the page, so you can fill in the blank. What number when I take away 7 gives me 8? Excuse me. That tells me the answer is 15. But mathematically speaking, to get the y by itself, we're going to add 7 to both sides. Y has to equal 8 plus 7, or 15. Now, it says we've got this equation, and we know that x is equal to 6. They want you to solve for y. Okay. So we're going to put a 6 right there in that location. So we get 2 times 6 take away y equals 8. Now, if 2 times 6 minus y equals 8, if you divide by 2, that means that 6 minus y has to equal 4. 2 times what number equals 8? 4. So we know that 6 minus y is equal to 4. Now let's get the y by itself. We're going to subtract 6 from both sides. We get negative y equals negative 2, so y is equal to 2. Now mathematically, let's think for a minute. If x was 6 and y is 2, that value is 4. 2 times 4 is indeed 8. So y has to equal 2. Now this time they said that x is 2. So let's put a 2 here and here, and let's see what happens. So when we do that, we get 2y times the quantity of 4 take away 2 equals 2 divided by 2. Now, this is a math we can do. This is a math we can do. Let's do those things first. 4 minus 2 is 2. If it's sitting in front of it, that means it's multiplying by 2y. And 2 divided by 2 is 1. Now, this means that 4y equals 1. And then we have to undo a multiplication. So divide both sides by 4, and y is equal to 1/4. The answer is B. 33. Where the x is sitting, we're going to put a 3. So this is going to be 5 times 3, which is 15. So I know that 1/3 of my y squared value plus 12 has to equal 15. Now to solve that, subtract 12 from both sides. We get 1/3 of y squared equals 3. How do we get rid of a multiplication by 1/3? Well, just multiply by 3, or 3 over 1. That's going to cancel that out. 3 times a third is 1. So we get that y squared has to equal 9. If y squared equals 9, then since 9 is 3 squared, we know y has to equal 3. So the answer is 3. Or you can think of the square root of 9 is 3. Okay, so there's that one. Just a few more pages to go. Sorry, just checking there. Here it says a farmer has 7 3/4 rows of radishes, 4 3/4 rows in another field, 6 1/4 rows in the third field. How many rows do they have altogether? That means we're going to add. So I'm going to show you how I'm going to write it. The first thing we check for is, do we have common denominators on the fractions? They're all fourths, that's great. To add fractions, just keep the bottom, add up the tops. 3 plus 3 plus 1 is a total of 7. And then we're going to add the whole numbers. 7 plus 4 is 11, plus 6 is 17. Now, you'll notice 17 and 7/4 is not our choice, because 7/4, 4 goes into 7 one time with 3 left over. So that's really 17 plus 1 3/4, which is 18 3/4. So be careful if this is not a proper fraction. How many times does 4 go into 7? One time with 3 left over, and that's what you add on to that whole number. In 35, it says we have a main road in Belleville, 7 3/10 miles long. So far, 2 3/4 miles have been repaved. How many miles have not been repaved? So we have to subtract. Now I'm going to write it like the one above, but this time we don't have a common denominator. 10 and 4 both go into 20. So I'm going to multiply this by 2 on top and bottom. I'm going to multiply this by 5 on top and bottom. And then I'm going to try to do the subtraction. Well, 15 can't come from 6. There's not enough there. So we're going to borrow. Now, when you borrow from a mixed number, let me show you what happens, okay? That becomes a 6. Nothing new there. But just add 20 to the 6. So, because we had one whole is 20 out of 20. Just add the bottom to the top. You get 26 out of 20. Now we're ready. 26 minus 15 is 11. 6 minus 2 is 4. Our answer is A. Let's go to 36. 4 friends went out to dinner. The bill, including tax, was $64. If they want to leave 15% tip and want to share the bill and the tip equally, what should each person pay? Well, first we need to know what the tip is. $64 times 10% is $640. So 5% is half of that, $320. So if we add the 10% and the 5% together, we get the total. That's your tip. But it was $64. We need to add on the $960, and the total be $73.60. And then there were 4 people. So we've got to divide that by 4. Now, since that number is a whole number, just bring that decimal in the up. 4 goes into 7 one time. 4 goes into 33 8 times. Bring down the 6. 4 goes into 16 4 times. perfectly, and so the 0 just finishes it out. The answer is B. So that is 36. 37. The Williams wanted to cover one wall in their living room with 1 foot square mirror tiles. The wall measures 8 by 10. How many mirror tiles will they need to cover? The area of a rectangle is length times width. So that's 80 square feet that they need to cover. The tiles are 1 by 1s or 1 square feet. So we would need exactly 80 tiles. 38. Kenji has 8 apple trees that each produce 20 bushels of apples and 12 apple trees that produce 25. In total, how many bushels? Well, if we do 20 times 8 for the one type of tree, that's 160 bushels. If we do 25 times 12 for the next set of trees, let me do that. You get 300. So if we total them up, 160 plus 300 is 460. So that's that one. So we've got this logo. They've given us some formulas over here. The radius is 10. The circumference of a circle, that's the distance around, is that. The area is pi r squared. The volume in the area of a cylinder, that. Okay, there we got everything we need, okay? Pete is designing a company logo by dividing his circle into 5 equal pieces. How many degrees are in an angle? So a fact that didn't tell you is that a circle is 360 degrees. So if we want to divide a circle into 5 equally spaced pieces, 360 divided by 5 is 72. So the answer would be B. And then it says, Pete plans to put silver-colored ribbon around the circular logo. So around a circle is the circumference. About how many inches of silver-colored ribbon need. Now, see how that it says that the radius is 10. The circumference of a circle is 2 pi r. This says equal to pi d. If you know the diameter, you can use pi d, or if you know the circumference is 2 pi r, either one. We know the radius is 10, so we're going to use 2 pi r. So that's 2 times 3.14. I think that's what they told us to use. Yep. And the radius is 10. So that's going to be 20 times 3.14. 20 times 3 is 60. The only one that's in the 60s is D. If you actually did the multiplication out, you do get, we're going to move the decimal place 2 over. We do get 62.8 inches. And then it says, if Peter wants to paint the entire circle of his logo blue, how many square inches will be needed? That's area. The area of a circle is this one, is pi r squared. Remember, our radius is 10. So 3.14 times 10 is 3.14 times 100, which is exactly 314 square inches. So the answer is 41C. We only needed the circle because it's on a flat design. We didn't need cylinder. Cylinder would be if maybe they're putting something in a can or something. Okay, last ones. How many 1 2/3 yard lengths of wire can be cut from 25? So we're really dividing 25 by 1 2/3. Okay, so let me show you how to do that. Mixed numbers are not helpful in multiplication or division. So 3 times 1 is 3 plus 2 is 5. So that is the same as 5 thirds. Now to divide by a fraction, just flip it over and we're going to multiply. So 25 over 1 times 3 over 5. Now there's a few different ways we can proceed. We can just multiply the tops with the tops and the bottoms with the bottoms and then reduce. But since 5 goes into 25, we can reduce ahead of time. 5 goes into there 5 times. So that becomes 15 over 1, or 15. So the answer is 15. 43, Joan received a discount of $4.80 on a book that originally cost $60. What is the percent of the discount? So what you can think of is this little equation, part over whole equals percent out of 100. Okay, so let's fill in everything we know. The part that they took off was $4.80. The whole value of the book was 60. And what percent would that be out of 100? Well, to solve that, you're just going to cross multiply. So 480 times 100 is 480 divided by 60. 480 divided by 60 is, let's see, 8 times, I believe. 480 divided by 60 is exactly 8 times. So the answer is 8%, or C. It says Dr. Warren purchased some medical supplies for $670. The sales tax rate was 6.5%. How much did he spend on supplies? Well, first we need to do the sales tax. We can do the same formula we did before. What is the part out of 670 if our percent is 6.5? We put that over 100. Or you can do 670 times 0.065. It works the same way. Either of those things will work for you. All that does is calculate the amount of the tax. So the tax is $43.55. So we have to add that on to the 670. So it's not A that ends in 55 cents. It's got to be D, using logic. But if you actually add it up, it is a total of $713.55. And then the last problem here, 45. Last year, about 2,400 people participated in the 4th of July parade. This year, about 3,200. What was the approximate percent increase? Well, it's always your new divided by your start, or your old. And then we have to take 100% away, because that will tell me how much it changed. 100% is your starting value. So if we do 3,200 divided by 2,400, it's the same as 32 over 24. They're both divisible by 8. That's 4/3, which is 1.333, which is 133%. So if we take off 100%, or take off 1, if it was in decimal form, it has gone up by 33%. So that's how to do it. Now, another way to do it, if you subtract, it went up by 800. 800 out of 2,400 is 1/3, which is also 33%. So if you just look at how much it changed and then divide by the original, you could also do it that way. So these are lots of things to study, lots of things to do. I would repeat the process. Watch the video again if you can. If you need any more help, just let me know. Thanks.